A good percentage of us are not sure how to go about this question. Can we use common base method? No, 10 and 7 are not common bases. So one thing we learned last week is we can create a common base by taking a log base 10 of both sides. So this is an equation. What we do to one side, we can do to the other. So I can take the log base 10, notice that there's a base 10 here if I don't write anything, of both sides. Because they did say to do it algebraically, right? Okay, so once we did that, do we have log laws that allow us to manipulate the equation to get x by itself? Last week, in one of your lessons, you developed this law. And this is on your 40 pre-cal formula sheet, right? That when you have a logarithm with respect to m raised to the n, can we bring the exponent to the front? Is that one of our log laws? That's called the power law for logarithms. Okay, so I need to algebraically use that to simplify this equation. Okay, so I'm going to use that right now because we have an exponent. So we move the exponent to the front. So it's 3x times log of 10 equals a binomial of x plus 5 times the log of 7. I don't have to put that subscript 10 in there. Okay, so now we can, on the left-hand side, just write that as 3x multiplied by the log of 10 equals, if I have a binomial in front, I can multiply that through. That becomes x times log of 7. Remember, log of 7 is just a number, right? It's just a number. So x times that number plus 5 times that number. Okay. Isolate x. So on the left-hand side, we want to bring all terms involving x to that side. So this term must move over. So I have x on one side, constants on the other. On the left-hand side, how do we get x by itself? Factor out an x. They both have x in common, so we can factor that out. So x times what is 3x log 10? That's the same as 3 log 10. Could we write log 10 as something nicer as well? Is log 10 1? 10 to what exponent is 10? Okay, we could write that as 1. I think I'll do that in the next step. This is log 7 here. And this is just our constant 5 log 7. Okay, so now I factor out an x. I can divide both sides by what I'm multiplying x by. I can divide both sides by 3 log 10 minus log 7. Divide both sides by what I'm multiplying by. Okay, so this cancels. I'm left with x equals whatever this becomes. And this is a calculator question. I need to use a calculator to simplify this. Just for the sake of what's obvious there, what happened to my board, Mr. Wheeler? What'd you do? I can't extend the page. Well, you could write this as 5 log 7 over 3 times 1 minus log 7. You did not have to show that, but I will. Can you enter that in your calculator? What do you get? Is it 1.961? Okay, double check that. Make sure you all know how to type that in, because a lot of people won't put brackets around the denominator and they'll get a different answer. Okay? So what does that look like? If we were to check our answer, does that mean that 10 to the 3 times 1.961 is equal to 7 to the 1.961 plus 5? Is that what we've done? Right? We solved for that letter x. Okay, so let's look at the marking key that the province gives teachers for that question. So you can mark your own. Remember, I'm not going to collect this. You get a half a mark for taking the log of both sides. Give yourself a half for that. You get 1 mark for using that power law that I talked about, moving the exponent to the front. You get nothing for distributing the x forward. We get half a mark for moving all terms involving x to the left. We have to factor out an x, and that leads us to this step where x is isolated, so they don't actually give any marks for the factoring part. And 1/2 mark for using your calculator properly, and half a mark for rounding. How many people got 2.5, 3? Okay. Any questions on that? There are 3 types of equations you got to be able to solve using logarithms. This is one of them. I think on 5.7 there are a few others that are big ones that you got to... Yeah, on page 425 there's a bunch of different types. If I look at page 424 and 425, I'm looking at numbers 9 and 11 and 12 are as big, important questions. Okay, so that leads us into what I want to do today. Is there anything we need to correct on 5.7? Make sure like number 9, 11, 12, you can do those. Hey, Kayla? 13B? Any others? 11B? Others? Yeah. 12D? Yeah, that one is like the question we just did, but there's a double base on the left-hand side there. Okay, I'll maybe do a little bit of the beginning parts of those questions. Let's start with 12D. How many people figured out 12D? Oh, good. That's a tough one. 12D says 3 multiplied by 2 to the x equals 6 to the x minus 1. I'm going to do a no-no right now. I'm going to show you what a lot of people will do on the provincial exam, and they'll lose 4 marks. There's no part marks possible. Can you do that? That's the big no-no of logarithms. Dylan will do that. I can make fun of him. You cannot do that. You cannot multiply powers with unlike bases. Okay? And unfortunately, even if you paint a Picasso after that, it's 0. Okay? There's some mistakes that inhibit your ability to get part marks. So these are unlike bases. On the left-hand side, in fact, there's a double base. We got to solve for an exponent. So once again, you got to take the log base 10 of both sides. Log of left and log of right. Here's step 1. Now what? Step 1, take the log of both sides. Step 2, use your logarithmic laws to manipulate the equation. Which log laws do I use? Mel? Power law on the right. So the power law says that we can bring the exponent to the front. I have just used the power law. The power law states that log base a of m to the n is n times log base a of m. I just used that there. What must be used on the left? Do we have a log law when we multiply unlike bases? Is that the log base a of m times n law? You had to have derived that last week. Mr. Metric would have said, when you multiply m times n, or 3 times 2 in this case, that can be broken up as log base a of, speak to me. Right. That's the addition law. The addition law can be used when we're multiplying two unlike bases. So, we'll do that here. Let's move this out of the way. Move this down. So what does that give us? That gives us log base 10 of 3. There's m plus log base 10 of 2 to the x. There's our new equation. Yeah?
Can you not factor out the 3, divide out the 3 at the beginning?
You could divide out the 3 at the beginning, but that might bring us to another no-no. So I'll do that over here on the board. So if you want to divide both sides by 3, this cancels. We're left with 2 to the x, but we're left with 6 over x minus 1 over 3. What's this not equal to?
2.
Not equal to 2. You cannot divide unlike bases as well.
What if that was just 6?
You could do that, but now if I take the log of both sides, I'm going to have to use the quotient law for logarithms on the right. Mr. Metric showed you this one, right? Where we divide, that actually becomes subtraction. Yeah. I think you're making the question a bit harder by doing that. But looking for that's good, Michaela, because sometimes if this was a 3, that would have been advantageous. I still can use the power law over here with the log base 10 of 2x, 2 to the x. So I'm going to make that x log 2 equals, might as well distribute this forward now, x log 6 minus log 6. Is this question now just like the warm-up question, the exam question? Yeah. So I'll stop there. I think that you can carry it through now. But don't forget, like this is a very popular exam question with the double base, and a lot of students won't be able to get marks past that. Tough to get part marks because lots of no-nos happen here. Okay, so that's 12D. Let's go look at 11B. Solve the equation. 11B says log base 10 of 2x plus 4 minus log base 10 of x plus 2 equals log base 10 of x plus 1. A few different ways we could do this. What did you guys do? Yep. Division law on the left? It's kind of telling you to do that, isn't it? That would work. So you wrote that as log base 10 of 2x plus 4 over x plus 2. And you left this expression on the right. Right? You guys know why this is, right? Because of the quotient law, m over n. Yeah.
You have to factor out the 2, right?
You could. That'll make life easier, won't it? Yeah. So that becomes 2x plus 2 over x plus 2. I didn't even see that right away. That definitely makes this one easier to deal with. So that's log of 2 equals log of x plus 1. Here comes another no-no. Somebody in this room is going to do this if you're anything like people I've taught before. Can you distribute the log through? Is this equal to log x plus log 1? No. It's the log of the result of x plus 1. The reason people start doing that, and it's understandable, did we just do a question where we had something like this? Can you distribute the binomial forward? Yes. This is a yes, yes. That's a no, no. You have to take the log of the result. Very common mistake there. So don't do that, Dylan. Don't do that. Okay. So, what are our options now? Can't cancel. Since the bases are the same on both sides, can we just say 2 has to equal x plus 1? That's not canceling the logs, though. That's just using the understanding. Because what I don't want to see is people dividing both sides by log of nothing. Okay, you can think of it as canceling the logs, but I'm scared if you divide both sides. Well, whatever. So since the bases are the same on both sides, can we equate their values? Yes. So that becomes x equals 1. Okay. Now enlighten me here. I'm going to show you another way to do that. For this question, this very well was the best way to do it. But there's going to be other questions where what I'm doing in green is going to be the better way. Okay. I am going to bring the log base 10 of 2 to the right and have the equation equal to 0. So that becomes log of x plus 1 minus log of 2. Are you with me? Often, the logarithmic equations work nicely when they're equated to 0. What do we do on the right now because of that? Can we use the quotient law and write that as x plus 1 over 2? Can we do that? Did Ms. Nemechek do any examples like this one? No? Okay, this is good we're doing this. So this is an example where the equation is equal to 0. Simplify as a single log. After you simplify as a single log, you can do what? Write it in exponential form. Can we use the definition of logarithm now? Why did Mr. Wheeler change my board? Oh, there it is. It's messed up. Messed up. So what's this as an exponent now? Come on, come on. Y equals log base a of x. A to the y equals x. Write it like that for me. What's the subscript? 10. There's a 10 there, right? 10 to the 0 equals, right, okay, go solve that. I know you're thinking, why are you making this harder, Mr. P? There's going to be some questions where this is the way you got to do it. They won't always be nice like this, where this log base 2 can be equated. So what's that equal to, Riley? 1 equals x plus 1 over 2. Cross multiply. Same answer, right? Okay, so the only subtle thing you got to remember, equate to 0, simplify the logs, change to exponential form, and solve. Say that one more time. Simplify to one single logarithm after you equate to 0, change to exponential form, and then solve for x. I hope you're writing that down. That's going to be coming up. Yeah.
What if they weren't base 10, like what if people had the same bases?
We're going to be doing in 5.9 different bases.
Okay.
Yeah. So let's just wait for that. Okay. So that's 11B. I did a little visit to 12D. What was the other one? 13? 13B? Who had trouble on 13B? Come on. Just the two of them? No way. Riles, you get that one? See? Raise your hand. Toddy, did you get that one? Yeah, you got that? Well, you'll have some time to work in the next period, and I can help you two out there if you're the only two. Okay. 5.8. Let's get started on 5.8. I know that we're not finished this one here. I saw a lot of blank papers out there. I'm not going to slow down, but I'm worried about those people that didn't do this exercise. They're not going to be happy later. I'm going to highlight that. I'm going to come back to this. All right, 5.8. Right here. Basically, word problems involving what we did in 5.7. What were the main types of word problems that we looked at before I left? Money. Compound interest. Okay? We're not going to use the get started to get started. This geometric series that we took last year is used to develop the proof for the future value and present value formulas. We're not going to take an hour to do that, okay? I'm going to save a bit of time here. But I will have you do this question. You should know how to do this already. I took this up before I left, but you are more powerful now. You know how to solve this algebraically. So go use your compound interest formula and tell me how long it will take for this $5,000 to double to $10,000. And do it algebraically. Mr. Penning, it's going to take you 23 years and a little bit for your $5,000 to double. That's a long time, 23 years. But that's a small interest rate, right? 3%. If we would have made this 500,000 and made the left-hand side double it, $1 million, would the answer have been the same? Brad? Yeah. Because what would you get when you take $1 million divided by 500,000? 2. So for any doubling question, did I really need to put 5,000, 10,000 in here? What could I do for any doubling question? Just make sure that this number is always double that one, 1 and 2? Yeah.
For the exam, do we leave it as 23.13 years, or do we have to round it up to 20?
Depends what the question says. This one said nearest year, so you say 23 years. Yeah, and if you leave it as that, you lose a half a mark. But the nice thing on the exam is you don't lose a half for every question. You lose a half once. They're not going to dock the Krause 10 times on the same mistake.
Because, like, in apply, if it was 23.1 years, then we'd have to round it up to 24 years. Yeah, because it would take it. Yeah, because at 23 you wouldn't have it.
No, I think you're okay here. And it said for us to check our answer graphically. Just for the sake of time, I'm not going to, but you guys know what that would look like, right? Would this be the investment piece? Would this be the doubling piece? And where they intersect is the 23 years part? Right? That's what we did when we verified all this graphically. This is an exponential growth graph that intersects a horizontal line. Okay, so let's look at a few other formulas that we're responsible for. Yeah, that's that one. We're going to go right to here. A little bit of reading. What page is this on? 431. Reading at the top. When a series. Go, Chris.
When a series of equal investments is made at equal time intervals, and the compounding period for the interest is equal to the time interval for the investments, the amount in dollars with future value FV of these investments can be determined using this formula.
The future value of the investment. What it'll be worth in the future. Okay, so here's the formula. Future value equals R is your regular investment, what you have invested. I is the interest rate for the compounding period. And N is the total number of investments. Okay, so that will be given to you not on your formula page, but with the question if there is one. Okay, so let's do one of these. Check for understanding number 1. This one. Determine how many monthly investments of $200. Oh, this is good. This takes the regular contribution into account. How many investments of $200 will you need to make at a 6% interest rate if the interest is compounded monthly for you to have $100,000 eventually? Okay, go ahead. Write down the formula, substitute in the quantities. The variables are given to you on page 431. So what do we put in for R? What's the regular contribution? Rouse? 200 goes in for R. Interest rate. Robert, what's your interest rate? 0.06, that's right. Compounded monthly. Monthly, so what do we have to do to the interest rate? Because the interest rate is always yearly. Do we have to divide by 12? Okay, so that is because, notice here it says 6% annual, once per year. We need to compound monthly, so we always take the rate and divide by the number of times per year, in this case 12. N is the number of times. Let me just get to the right page here. N is the number of total investments. Okay, and we want it to be worth future value. The future value is $100,000. Whoops. Okay, so algebraically, what comes next? What would make sense in this question? Simplify with some brackets, absolutely. What else? Divide both sides by 200. Yeah. Okay, so I'll let you get ahead of me. Go and solve for n. Solve for n. Who's got something? Shayon, what would you do? Give me an algebraic step. Yeah, we can multiply both sides by 0.005. Right? That would make sense. Okay, so I'll do that here. I'll just write this out for Dylan. 100,000 equals 200. Bracket 1 plus 0.005 to the n minus 1 square bracket 0.005. So essentially cross multiply. What is 0.005 times 100,000? 500? Someone say that? 500 there? 500 equals 200. 1 plus 0.005. Why don't we simplify that now too? That becomes 1.005 to the n minus 1. Okay, now what? Divide both sides by 200. That makes it nicer. 500 over 200 is just 2.5. So that leaves us with this. Now what? Yeah. I'll put both screens up here. Hold on. I multiplied both sides by 0.005 to get this 500. Across multiply. Now what? Josh, now what? You could log everything, but I think we can make it nicer on the right. You tend to want to get the exponential function isolated. We got a 1 here. Can we move that over? Add 1 to both sides. So add 1 to this side, add 1 to this side. 3.5 equals 1.005. That is nice. Okay. You could take the log of both sides at this point, but you're going to get a really tougher equation to deal with. Did Mr. Nemechek write down the steps of solving these logarithmic equations? Because I've been saying them to you, right? Step 1. Take the log of both sides. Step 2, write as an exponential equation. Step 3, use your log laws. I think maybe later we should take a few minutes to do that. Now what? Right, now we have an exponential equation. Take the log of both sides, because these are unlike bases. Yeah. Yeah, so Mel, you're essentially talking about taking the log of both sides, right? You need to have logarithms in order to do that, right? So now we take the log of both sides. Now we use our log laws to simplify. Does the n go to the front because of the m to the n rule? You guys last with me this week. We got a big week here. There. Did you do that? Yeah. Well, they're subtracting 1, so I'm just adding 1. Add 1 to both sides. Or in grade 9, we just said move the 1 over. Negative 1 over, it becomes plus 1. We got to move that negative 1 over to join 2.5. Right? We'll move that minus 1 over to join the 3. You can't subtract these because this is a power, and that's a constant. I just added this. 1.0005. And you got to subtract 1. You got to move the 1 over. You got to get the exponent by itself. Now what? Divide both sides by what you're multiplying by, 1.005 log of 0.05. That cancels and equals. What do we got? 251 point, and they want to know how many monthly, how many? Well, let's round up to 252. What's that stand for? Oh, this is awesome. What does this represent, folks? Go, as you say. How many monthly investments? Of how much? We'll get you what? $100,000. If you make 252 investments, contributions, of $200 into this plan, you should have 100,000 at the end of it? What are you curious of right now? I'm curious of something. What do I want to punch in my calculator? What does Penny want to do right now? I want to go 252 times 200. That's what I want to do. Do that. What's 252 investments of 200? What do you get?
50,400.
Is that how much I put in? 252 investments of $200 is a total of? Say that, LaFleche.
5,400.
No.
2 times 200.
252 times 200. What's that equal to?
50,400.
50,400. So I thought you said 5,400. If I put 50,400 in, I'm going to get 100,000 out. That's the power of the RSP because you're actually contributing to it. Oh, that's good. So on any exam, they'll ask for a therefore statement to bring out of you what you just found. Okay? All right. Let's take a 5-minute break. Disneyland. Kolonosky? Colonoscopy? Klinsky.
The clock started, guys. Get going.
It's for Marks.
Get another snack. Is this a back-to-back period?
Yeah. All right. But I came around the room, I think everybody pretty much got the same equation as I got here. Now what? Move the 1 over. Move the 1 over. Move the 1 over. I've lost the question. Where is it? Oh, I've lost the question. Is that it? Is that it? There it is. Okay, so I move the 1 over. I subtract 1 from both sides. That leaves me with -3/4 equals -1.005 to the negative n. Now what? Divide both sides by -1. Absolutely. That leaves me with this. You could do that at the end as well. Now we have 2 unlike bases. Here's another exponential equation. Take the log of both sides.
How do you know when you can just do the log here?
One more time.
How do you know when you can just like put a log in there? Like I feel like we've never done that.
Taking the log of both sides occurs when you have an exponential equation with unlike bases. When you've simplified it as far as it'll go into an exponential equation with unlike bases. So now we take the log of both sides. And I chose to move, when I took the log of both sides, I applied the exponent law right away. Move the minus n to the front. Divide both sides by log of 1.005. Do you get 57.7 payments of $300? That's n.
How did you get rid of the negative? Yeah, can you show me that on a calculator?
This part on the calculator?
Yeah.
Okay. Okay. Eyes up here. Quiet. Toddy, quiet. Which part? This part here? What part do you want on the calculator?
I thought you can take the negative log. Or can you just not take
It's not the log of a negative number I'm taking. It's a number times a log. What you cannot take is the log of a negative number.
Oh,
Okay. Which part, do I need to do this on a calculator?
yeah.
Okay, so here goes. Log of 0.75. I'll just press enter. There's the top. And I want to divide the top by log of this number. So that's log of 1.005.
Yeah, it was supposed to be negative log.
Oh, there, I didn't see that. That's right here, sorry. So that would have been a positive 57.6, right? Okay. So there it is. Now what have we just figured out? To buy the car, Elizabeth needs to make 57.7 payments, 58 payments of $300. What does that turn out to be? On the calculator, Brooklyn goes 58 times her monthly payment, 300. What do you get? 17,400. How much more is that than the car purchase price? 2,400 more. What is that? What does that represent? interest. The bank is making $2,400 on you because you kept your monthly payment low. I know another story. A friend of mine's nephew went down to AutoList on Regent. They're the company that advertises, bankrupt, we'll give you a loan. No job, we'll give you a loan. No matter what your financial situation, we will sell you that car. His nephew, 21 at the time, I think was working at working at a burger factory or some sort, went down and saw a Pontiac Sunfire 10 years ago that he liked. Bought a brand new one. Negotiated the price with the salesman, but he knew that, and the salesman tried to sell him the lowest monthly payment. He signed off on a contract on a monthly payment of around $250. So he came home and told his parents, who's a friend of mine, that I bought this car, I got a great deal, it's only costed me $250 a month. No problem. What did he fail to calculate? What did the salesman fail to show him? Over the extent of the loan, of making such a low payment, how much interest he was paying. You know what it turned out to be? It was 11 years of interest over and above. That Pontiac Sunfire that he bought, he thought, for around $16,000 was going to cost him $32,000. If he was to keep the contract for that car, he would actually have paid double. He could have bought a BMW, a smaller Beamer, for the same price as that Pontiac Sunfire. But here's where it gets really good. The contract he signed had a little clause in it that he's not allowed to renegotiate the contract for 3 years. His parents were livid. They wanted to go down there and renegotiate the contract, right? They couldn't for 3 years. So once the third year came up, they were allowed to go in and say, okay, we want to put $10,000 down. And there was hell to pay. Yeah. True story. I could give you his name. Okay. Example 3. Earthquake. Let's go to the middle of page 433 when it says when physical quantities. Let's get ready to read there. Kayla.
Part B, it said how much interest was paid on the car loan.
So we're going to use that formula. What goes in for M? Do we know the magnitude of that earthquake? Yep, it was 9.5 on the Richter scale. Okay, so that's equal to the log of L over S. Have we written this as a simplified logarithmic equation at this point? We have. Can we change it into exponential form? Okay, so what would that be written as? Yeah, so think of your 7 rule. 10 to the 9.5 equals L over S. And the question was, calculate the intensity of the earthquake in terms of a standard earthquake. They want to know how much more intense was it versus the standard earthquake. Was it twice as intense? Was it 10 times more intense? How would we work that out? Cameron? S is your standard earthquake, right? So do we want to know how much times greater than S it was? Because S is your standard earthquake intensity. So we can cross multiply, right? L over S equals 10 to the 9.5. Multiply both sides by S. And what's this saying? This is saying that this earthquake, L, is 10 to the 9.5 times as intense as a standard earthquake.
What? That's not right.
Mhm.
Where did this 10 come from and where did the log go?
Okay, so the 10 is, we changed it into exponential form here. This is a base of 10, right here. So it's the 7 law. 10 to the 9.5 equals L over S. 10 to the 9.5 equals L over S.
How are you doing that and not do log I minus log S?
Because as I said earlier, remember I showed you the second way to do that one equation? I said sometimes this strategy will be useful. This is a case where that is. You are right, Michaela. You could write this as log of L minus log of S. But you would have been expanding the logarithm instead of shortening it. I have shortened it for the purpose of changing it into exponential form. It's just made it, I was able to get rid of the logarithm by doing it this way. So therefore, what we have just found is the Chilean earthquake was 10 to the 9.5 times as intense as a standard earthquake. Okay. Well, I've talked enough here. Let's get working. We've got two things I want to see get done. I want 5.7's got to be finished. 3 to 14. Okay, I'll be checking that tomorrow. A lot of you are finished, but there are some of you that aren't. And then 5.8. So the two things we got to be finished are this and this. Five 5.7 is the big important exercise in this unit. That's a big one. Like if you can't do those equations, you're going to have trouble. You're going to have trouble in 5.8 if you had trouble in 5.7.